Mark Hopkins initiated the merger negotiations and conducted most of the L5 side of the discussions, which led to the creation of the National Space Society from the L5 Society and the National Space Institute in 1987. He has received degrees in economics from Caltech and from Harvard. He has written numerous space economics articles. Mark currently serves as National Space Society NSS Senior Vice President and as the Senior Operating Officer. He has served in one officer position or another in L5 and NSS, and this is at the national level, not the chapter level, for 25 of the last 31 years. And we're looking for our presentation.
We're looking for a presentation which doesn't want to come up.
There you go. If you want a laser pointer, I have one for you.
No, I don't need a laser pointer.
All right.
All right, I'm going to not do the title that Anita suggested, and instead do the inevitability of space settlement and economic argument. Next slide. Just give you a little advertisement here about National Space Society in case you don't already know. I'm Senior Vice President. We're a nonprofit international organization headquartered in Washington, D.C. This is our annual conference. Next one will be in Washington, D.C. We were founded by Wernher von Braun in 1974. We're the world's leading grassroots advocacy organization that supports the human spaceflight program. And our ultimate goal, which is in red, people living and working in thriving communities beyond the Earth, and the use of the vast resources of space for the dramatic betterment of humanity. Assuming that a board motion passes on Sunday, we'll add the italic stuff. The italic stuff.
Oh, you want to go back and look at?
See?
Yeah, that.
See the italic stuff?
Yeah.
Okay.
Yeah,
And if not, then we'll just have the original stuff. Now, according to Michael Griffin, our NES administrator, one day, I don't know when, but one day there will be more humans living off Earth than on it. Next. What I'm trying to get through, the fundamental point, is that there are no limits to growth. That's because the vast majority of resources in the solar system are in space rather than on Earth. And in order to understand exactly, in order to get a gut appreciation of what I'm talking about, let's ask the question, suppose we took some of these resources and used them to build land area. How much land area could we get? And let's have the next slide. I'll show you technically what do I mean by building land area. This is space settlement designed by Gerard O'Neill, and which also NASA was involved in. And here are two cylinders. Each cylinder is 20 miles long, 4 miles wide, and an arrangement of mirrors so that the sunlight hits those mirrors, bounces through, and goes through the windows. These cylinders are spun, so you have artificial gravity on the inside. Next slide.
I'd like to point out that there's another one right there. So the idea was to build many of these.
That's true.
Pardon me for interrupting, but I'm rude.
That was good stuff. You keep being rude.
I'm obnoxious.
But Anita, you're a lot of fun. So.
Thank you.
Okay, here's the inside of one of these. And the idea is to build land area. Not just any land area, but a really nice place to live. Here we have streams and trees and clouds, etc. Actually, can you dim the light a little bit?
You can try the controls back there. You might be able to get it so, yeah, beauty, good.
Okay, next slide. This is another view of the inside. Again, I want to emphasize, these are very, very nice places to live. Next slide. This is one which has just been generated by the National Space Society. We held an art contest for a number of reasons, partly to get art for our 2008 Space Settlement Calendar, but also because we need art for a great number of purposes. No space settlement art worth mentioning has been generated since the last 70s. There's now an explosion of space settlement concepts throughout society. We need more art, so we generated more art, and here's an example. Again, an interior view of a space settlement. Next slide. Okay, let's get back to land area. Now, if we chew up the material which is in the asteroids, which is roughly the right composition, and we build space settlements of the type that I was talking about here, last slide, there's enough material to build a land area which is 1,000 times land surface area here. Now think about that for a moment. First of all, we're talking about not average land area on the Earth. We're talking about really nice places to live. So no tundra, no deserts, none of that. Furthermore, and then think about that number. Historically, when civilization in some sense expanded to the New World, okay, that was a big deal. The New World is significantly smaller than the Old World. Okay, what we're talking here about potential expansion of something which is vastly greater than what we have now. The impact would be truly enormous. All right, that's the asteroids. Somewhat later in time, we could then expand out and chew up the moons of the outer planets. If we did that, there's enough material to increase the land surface area we're talking about by another factor of 100. And if you go to the Oort cloud, which is a large cloud of comets, which are sort of form a sphere around the solar system as a whole, there is enough material there to increase the land surface area by another factor of 10. Now we're talking
10 times the previous step?
Yes, yes. So the total is 1,000 times 100 times 10, or 1 million. Very big number. But it's peanuts compared to the situation with regards to energy. The sun puts out, and it's of course renewable for a very long period of time, the sun puts out energy, which is 2 billion times the amount of energy that the human race currently uses. And when I say the amount of energy the human race uses, I'm including all the energy we use to light the sky, to warm the planet, etc. To define energy the way we normally do, which is like coal, and electricity, and things like that, and that number 2 billion goes well over a trillion. We're talking very big numbers. Nor do we need to stop with the solar system. Next slide. The closest star, it's actually a system of 3 stars, is Alpha Centauri system, and it's 4.35 light years away. Our Oort cloud extends out to about 3 light years. Now, one of the stars in the Alpha Centauri system is very similar to the Sun. If we make the assumption that their Oort cloud extends out as far as ours does, that's 3 light years, they're only 4.35 light years away. That means the 2 Oort clouds overlap by more than 1 light year. If you have a civilization which is expanding out from Earth, past Pluto, into the Oort cloud, it sort of naturally crosses that star bridge into the next system without doing anything particularly special. Nor is that necessarily the Inevitability. There are on the order of 300 billion stars in our galaxy, and astronomers believe that the vast majority of these stars have at least some stuff circulating them. Not necessarily planets, certainly not necessarily Earth-type planets, but comets, asteroids, stuff like that, all of which can be converted into space settlements. And so we're talking about large numbers of space settlements, large amounts of land area for humans around each of the stars. Next slide. Are these resources obtainable? We'll just talk about the solar system resources. And the answer is yes. And that's because of the twin forces of resource exhaustion and technical change. This is an economic argument. These twin forces are virtually unstoppable. Now, it is possible to stop them. For example, if an asteroid hits the human race, hits the Earth tomorrow and kills everybody, that'll stop them. But it takes something like that to break these things. And get a gut feeling of that. Consider as an example the history of the oil industry. This started in 1859, and the first gusher was very easy in a technical sense to obtain. Sort of kick the ground and you got a gusher. Okay, as time went on, the amount of the places in Pennsylvania where you could kick the ground and get a oil gusher were all used up. Resource exhaustion. And if that had been the entire story, the price of oil would have skyrocketed, and that would have been, nobody would buy any more oil anymore, and that would have been the end of the industry. But there was a second force which was going on, and that was technical change. What technical change did is it made things easier to get in terms of oil, and kept the price of oil down, even though it was becoming technically more difficult to obtain. And it meant that oil resources in Pennsylvania, which were not originally economically viable, became viable because of the improving technology. It also meant that it made increasing sense, in economic sense, to go to places other than Pennsylvania to get this oil. So lo and behold, they went to some place like Texas, and I think most have heard of it. And then it led to increasingly exotic climes, such as the North Slope of Alaska. And more recently, they're now drilling several miles down to the ocean in the Caribbean before you get to the ocean floor, and then they start to drill over it. Well, if you look at resources in general for the human race as a whole, and for the planet Earth as a whole, the same thing is happening that is happening to the oil industry. Namely, resource exhaustion is setting in, which depletes the resources which are easily available. And that is being countered by technological change, which makes other resources increasingly easy to get. And these things are pushing us more and more to more and more exotic climes for resources in general. And these same trends will eventually push us to a true bonanza for resources, which is outer space. Next slide. Why resources are important. The average American per capita income is about 7 times that of the world as a whole. Now that's average. I mean, there's a lot of poor people which have much, much lower per capita income than the factor of 7 suggests. Now let's assume, for the sake of the argument, that one of the things the human race as a whole wants to do in the future is raise the standard of living of the average person up to what the average is in the United States today. That means, to a first approximation, that you need to increase the amount of resources we're using by about a factor of 7. And you want to do that in a way which is reasonably environmentally friendly. So where are we going to get these resources? In space is the potential answer. And of course, the 7 is much too small, because the truth of the matter is, the population of the world is increasing, and the per capita income in the United States is increasing, and rightfully so. And so to really raise everybody up to where we're going to be by the time they reach us is going to be a much bigger factor than 7. Of course, it's possible, as I mentioned before, to stop these twin forces if you have a sufficiently large catastrophe. As it turns out, that these resources are important not only for the reasons that I mentioned before, but because they also reduce the threat that of these catastrophes. Some of these threats they eliminate directly. For example, possibility of an asteroid impact. If you're chewing up all the asteroids, if you chew up all the asteroids, then that's not a problem. But even in the relatively near term, where you have the sort of technology we're talking about, detecting asteroids and deflecting them as compared to chewing them up is trivial. As regards to energy, there's this enormous amount of energy in space, and there's a lot of ways which people have suggested for bringing some of it down to Earth, some of which I'll mention in a few moments. That you could use space to solve the energy problem. Other threats in general are mitigated by the fact that the human race becomes rich by getting the technology to utilize these resources and doing so. As a consequence, it can use some of its wealth to take whatever measures are necessary to reduce the probability of these threats. Okay. Here are some of the ideas which have been floating around for the relatively near term about how you could start exploiting some of these resources. Now, I'm not saying that any one of these particular ideas is the correct one or will work, but the fact that there's a large diversity of these ideas already suggests that at least one of them will happen in the near term. And even if none of these do, in the long term, because of the twin forces of resource exhaustion and technical change, there are some method will come forward to actually accomplish this. These include such things as the Vision for Space Exploration, which is NASA's core program, which is sort of doing the precursor activities to a lot of these things. One of the reasons for going back to the moon, official reasons for NASA, is to enable eventual space travel. That's official. Other possibilities is mining the moon for helium-3, which has been suggested by a former astronaut and former Senator Harrison Schmitt, who will be our dinner speaker on Sunday. And his idea is that helium-3 is a fuel for potential fusion reactions in the future. It has a huge advantage in that it doesn't cause significant radiation, unlike many other types of fuels. There's arguments that there might be heavy concentration of platinum group metals on the moon because of asteroidal impacts in the past. There are suggestions that we could collect solar power on the moon and beam it to Earth. There's a whole bunch of varieties of ideas with regards to space solar power satellites. We have satellites in space, collect the energy of the sun, using, say, solar cells, one of many possible possibilities, converting that to electricity, beaming that down to Earth using microwaves, and then converting that back to energy and feeding it to the power grid. There are one possibility, which is a subset of the space solar power thing, is to use asteroidal and or lunar materials to build a large number of components of space solar power satellites. And the argument there is that could reduce substantially the cost of doing so, because the cost in terms of energy of getting something off the moon, because it has a lower gravity well, is only 1/6 of the cost of getting it off the Earth. In the case of asteroids, there's no gravity well worth mentioning at all. There's even talk of using some resources in space to build large numbers of sunshades to reduce the amount of sunlight which hits the Earth by a small amount, say a few tenths of a percent, and use that to stop global warming. Next slide. This is just an artist's depiction, early version of a space solar power satellite. We have a large field of solar cells here, collecting energy, which is then beamed down to the Earth, where there's a antenna which gathers it and converts it back into electricity.
Is there a place where all this art's available from, that you're from your side?
This art is generally available. Most of the art is available from NASA, etc., except the one that I showed you that is our recent.
With the beach.
Yeah, the beach. Next slide. According to John Marburger, who's the president's science advisor, President Bush's space vision is to begin now for a future in which the material trapped in the sun's vicinity is available for incorporation into our way of life. Next slide. According to General Pete Warden, who's speaking tomorrow morning, and is director of NASA Ames, we are expanding into space to provide unlimited potential for our children, potential to solve Earth's most pressing problems. We are optimistic that the vision for space exploration will open the entire sphere of the inner solar system to commerce, including such possibilities as addressing our energy and global warming crises. This is a poster which gives the official NASA reasons for returning to the moon. There are 6 of them. The one that's circled, you can read it, says to enable space settlement. The one which says economic expansion basically says to expand the economic sphere of the human race to include the moon. Next slide. Summary. The vast majority of the resources of the solar system are in space rather than on the Earth by a truly large margin. Barring disaster, twin forces of technological change and resource exhaustion will in time push us into space, making these resources available to us, and thus providing humanity with a hope for the future. Next slide. Closing quote. And again, from my regret. The single overarching goal of human spaceflight is a human settlement of the solar system. Emphasis mine, no greater purpose is possible.
Wow.
Questions?
And I have to confess, I screwed up on the timing. We have over 10 minutes for questions. I messed up on my timing.
No, you
I was
didn't.
giving you hand signals.
No, you didn't.
You were right on the time.
Of course.
So we do have 10 minutes for questions.
Yes.
You're an economist,
Yes.
and you've been around this issue for a long time.
Yes.
Did you attend the 1975 Ames session with Gerard and Neil?
I did.
A lot of these same issues were raised then, and same options. Other than the fact it's 30 years later, what's the difference between then and now?
Oh, enormous difference, and that's because of the impact of the space movement in general, and first the L5 Society and NSS. The L5 Society and National Space Institute merged in 1987 to create the National Space Society. And what's happened is the ideological penetration of these ideas increasingly into society as a whole. I mean, when we did this back in 1975, everybody thought we were nuts. I remember going to a Limits to Growth conference shortly thereafter. In those days, limits to growth was a big deal. And as a consequence, we were playing off that idea by saying, oh, the limits to growth, here's the solution. It's very similar to the situation we have today with global warming. And so I went to this big, fancy conference, and I was a graduate student at the time. Of course, my graduate has disappeared since then. But anyway,
Clearly.
I went up, and it was dinner. It was after dinner, and these 3 high officials in the U.S. government were playing pool, and I won't tell you who they were. So I went up to one of these guys and was trying to make a shot, and he sort of looked at me, and he sort of moved around the table. And I followed him, and kept talking, and he sort of moved around the table a little bit more. And I followed him, and he started talking, started moving around the table. Got about 3/4 around the table, and finally dawned on me, this guy thought I was totally bonkers. Well, see, this isn't true anymore. We have the NASA administrator, this really conservative organization, which is like a dinosaur, okay, who's now saying the same things we are. We have people like we have Hopkins, Stephen Hopkins, very famous physicist, was saying the same sort of thing. In an ideological sense, in a sense of values, in a sense of really what people think about in terms of a desirable future for humanity, compared to where we started from. We're like more than halfway there.
Not to mention that this has been written into the 2004 transportation budget, right? Some of the elements of
The Vision for Space Exploration is the core program for NASA now. And what is one of the 6 reasons? Actually, one of the 2 most important reasons, if you ask them, is to enable space travel. This is huge. Next one. Yes.
Yeah, you didn't talk about the political input into this process. What makes you think that the political process would not turn extremely negative with regards to space developments over the next 5 to 10 years?
Well, first of all, even if it does, we'll win in the long run. Okay? And there's a limit to the stupidity of American politicians.
Well, you're optimistic.
You want to place money on that one?
I knew I would start an argument, but look, I said a limit. I didn't say how low the limit was. I don't know. Look, we could lose the election in terms of the ideas we're talking about here, but we have one huge advantage, and that is our ideas are extremely powerful. Okay, and ideas have a way of penetrating society, particularly a free society like the United States. And more people will see that your ideas are correct, and eventually that will make a difference. And that is happening big time. Right now it's happening big time. A lot of these ideas are penetrating very fast, and that is your strongest thing to stand on. And of course what we're doing at NSS is trying to promote penetration of these ideas as fast as possible. And politicians do respond to ideas. They do respond particularly to what people in society as a whole think they should respond.
The general idea is there, and I agree with you fully on that in terms of there's resources out there that we can tap. Why isn't there the realization that we don't have to wait for 1,000 years? Because when you listen to Griffin and people in NASA talk, all it says is universal from official standpoints. I always get the impression that they're talking 100 years, in 1,000 years, something. Why is there reluctance to say we can do this now?
Well, that's look, Griffin is in charge of NASA. Not everybody in NASA agrees with Griffin, particularly when he's saying these statements. There's a limit to how far you can get out from his troops. And I think personally that if you pull Griffin aside, he would say something more along the lines of what you're talking about here. But just what he's saying now is incredible value, and it makes the life of organizations like NSS much easier, because we can go out and say things which are much more radical than Griffin. And Griffin knows that we're right. He's just in a position he can't do. He has to deal with politics. And next question. Yes.
To what extent do you think, compared to 30 years ago when a lot of this stuff came up, that the technology in society has caught up with the ideas? I mean, back then, they were going to do it with the shuttle, which was absurd. But
Well, back then we thought the shuttle was going to fly 50 times a year.
yeah.
Thank you very much.
Back
Technology.
then, the number of people who had computers in their homes was extremely small. Today, it's almost equal to the number of people who have TVs in their homes.
Well, there's no question that my personal opinion and the opinion of many people that NASA's been moving much too slow, and slower than expected, for a host of reasons. But it has allowed the ideology, the ideas, time to penetrate. Because, back then, ideas of space settlement, even if NASA had moved rapidly, were not on the NASA agenda. And ultimately, what happens, particularly in a world which is increasingly getting rich, the average per capita income in the world today is increasing faster than any time in history. When that happens, what economists will tell you is that people increasingly stop worrying about things like whether they're going to have a job next week, where the next meal is coming from, and start worrying more and more about more philosophical things like what is the future of the human race, what is really important, why am I here on Earth, and what should I do so that I have left a mark that I've contributed to the human race. And when that happens, and as increasingly happens, then all the ideas we started talking about become increasingly important. So, as the human race gets richer, eventually the human race is going to be in a position to get the future it wants. So the real issue becomes, do we want this future I've been talking about, or some of the other ideas which have been floating around, such as a future where you don't leave the Earth, you reduce consumption substantially, you limit population growth to like zero and actually go back the other way. You only use renewable resources. You don't like technology very much, except possibly in very limited areas. You have sort of a static society. It's green in a nice environment, although not as nice as we can get, what I've been talking about. It's really boring as compared to, it boils down to sort of a three-word description, which is Star Trek future. A future which is dynamic, expanding, human race spreading across the solar system and later into the galaxy. A future where there's always new possibilities, there's always new frontiers, not only in the physical sense, but in the idea sense. The sort of future which I think is vastly superior, and I suspect most of the people in this room do. Now, to some extent, what we're doing is a war of ideas between our future and this alternative future. And winning that war is very important. And I intend to do that. Next question.
Yeah, I just wondering if you could maybe get some people that know James Cameron to help us make like a space settlement documentary or even a movie.
That's great. You know anybody that knows James? Actually, we have some contacts with James Cameron. That's a good idea. Yeah, but also we're working with a group right now, which is run by Howard Bloom, who is a new governor of the National Space Society. He's a real media guru, and he is putting together a whole host of ideas for his media contacts to get some of these ideas out. The most recent one was that, due to some of the discussions he's had, is the Discovery Channel has put out an RFP for a new show, which will be called Colony. And the idea here is to have a future where things like this have happened, and it's a fictional show where you have some drama and people and characters running around. And that RFP that people have already replied to, it's on the list as far as it's making some submissions. And what Howard Bloom's group did, which NSS is intimately involved with, is they put forward a future which looks like the board of directors of the National Space Society created this future. So it's very much in the context of what we're talking about here. If that goes, and there's a whole, and it's not just the Discovery Channel, this is sort of exploding now through the media. A lot of people who are interested in shows of this nature, movies, one form or another. So it's going to get out there, and when that sort of thing starts happening, then you can penetrate much more the average person. So right now, things are very exciting because things are really moving fast in our direction.
Yes, Mr. Bloom, what is his background? Is he a TV guy, movie guy?
Howard Bloom started out in academia, then got tired of that, and went off and got into the media. He put together the largest and with the highest level of revenue company for doing PR for rock stars for a while. And he has a sort of a career where he, on a philanthropic sense, will go in and take relatively small movements that he thinks are cool, and using media to build them up into much bigger movements.
Is he here by any chance?
He's not, unfortunately. He was at the last ISDC, but he's a cool guy.
How do you reach him?
Google.
Yeah, Google him. He has this fantastic website. Google Howard Bloom. Fantastic personal website.
And we're out of time. And Mark, thank you very much.